Today we have a velocity time graph question. Two objects, the same starting point, same direction, and we need to find the distance between them at t equals 12 seconds. At first glance, object A looks straightforward. It's a flat line, means constant velocity. So distance is just v times t. Simple. But when you look at object B, it sits still for the first 2 seconds and then speeds up, holds that speed, and then slows back down to a stop. And your first instinct might be, do I need a different formula for each phase? Do I calculate acceleration first? Where do I even start? Actually, let's go back to basics. Take this simple formula, d is v times t. V is on the vertical axis, and t is on the horizontal axis. So when we multiply them together, what we are really doing is finding the area of the rectangle underneath the line. The width of the rectangle is the velocity v, and the length is the time t. That's all d is v times t is. It's just an area. And here's the beautiful part. That idea doesn't just work for constant velocity. It works for any motion on this graph. Speeding up, slowing down, holding steady, the area underneath that line is always your distance. So instead of worrying about which formula to use, we just need to find the areas. The rectangles, triangles, trapezoids is pure geometry. Here's exactly what we're going to do to find the distance between A and B. So first we'll find how far A traveled. That's going to be dA. And then we'll find how far B traveled. So that's going to be dB. Then we subtract the two to get the gap. So the distance between them will be dB minus dA. Both distances are just the areas under the graph. Let's find them one by one. A is a rectangle. The base or the length is 12 seconds. The height is 20 meters per second. So dA equals v times t. V is 20 meters per second multiplied by t, which is 12 seconds. That's 240 meters. Now B, and here's where it gets elegant. Look at the shape that B's line makes with the time axis. B sits at 0 for the first 2 seconds, then rises to 40, holds at 40 for a while, then comes back to 0. What shape is that? That's a trapezoid. The top parallel side is the flat section where B is doing 40 meters per second. From this moment, which is the 5th second, to this moment, which is the 9th second. So that's 4 seconds wide. The bottom parallel side runs along the time axis from t equals 2, where B first starts moving, all the way to t equals 12. So that's 10 seconds wide. And the height of the trapezoid is 40 meters per second. So the area of this trapezoid, or the distance that B travels, dB equals half the sum of the two parallel sides times the height. So it equals half of the top is 4 seconds plus the bottom is 10 seconds. Then multiplied by the height, which is 40 meters per second. And this gives us 280 meters. One shape, one calculation. Now we have both distances. dA is 240 meters and dB is 280 meters. All that's left is to subtract. So delta D is dB minus dA. It equals 280 meters minus 240 meters. So the gap between them is 40 meters. So the correct answer is B. So every velocity time graph question about distance comes down to one thing, the area. So you identify the shapes and then calculate the areas. It doesn't matter how complicated that graph looks. It's always just geometry. See you in the next one.